Ever thought about a day that never ends? Well, what if the Earth stopped spinning? The effects might be more terrifying than you imagine.
That would be disastrous. Disastrous, because right now, here in New York, you can calculate at our latitude, we are all moving with the Earth at 800 miles an hour, due east, because Earth is rotating. If you stopped Earth and you weren't seat belt buckled to the Earth, you would fall over and roll 800 miles an hour due east. It would kill everyone on Earth. People would be flying out of windows, and that would just be a bad day on Earth. I'm just saying. Now, if somehow we all slowed down, so anything not bolted to the Earth would fly due east, 800 miles an hour. That's what happens to you in a car if you hit a brick wall and you're not wearing a seatbelt. You keep going. That's why you get hurt in those kinds of accidents. But if somehow we all slowed down with the Earth, then okay, that's fine. I mean, people think, well, somehow we'll be weightless or we'll lose our atmosphere. No, it's just that you'll have really long days.
From the colossal reshaping of Earth's very form to the harsh divide between eternal day and everlasting night, this is what would happen if the Earth stopped spinning. Imagine a day when the world stands still. Not metaphorically, as in a pause from the hustle and bustle of daily life, but literally, as in the Earth ceasing its rotation. It's a scenario that seems more suited to science fiction than reality. Yet, it invites us to probe the intricate dynamics of our planet and understand the importance of its incessant spin. This essay explores the hypothetical scenario where the Earth stops spinning, its consequences on various aspects of life and the environment, and the scientific principles behind these effects. Our planet spins on its axis, an imaginary line running from the north to the south pole. This rotation is responsible for the cycle of day and night we experience daily, with a complete rotation taking approximately 24 hours. The Earth's rotation has a profound effect on weather patterns, climate zones, and even the shape of Earth itself. To understand the impact of Earth ceasing its spin, we must first appreciate the integral role its rotation plays in life as we know it. To begin our exploration, let's make a couple of assumptions. Firstly, the stoppage of Earth's rotation isn't abrupt. It slows down gradually over billions of years. An abrupt halt would be cataclysmic, causing everything on the surface to continue moving at the same speed due to inertia, leading to widespread destruction. Secondly, we'll assume that the planet's gravitational pull remains unchanged, as it's primarily determined by the Earth's mass rather than its rotation. We will also ignore any celestial causes and effects, such as changes in Earth's orbit around the Sun, focusing instead on the terrestrial consequences of this scenario.
It was spinning, it was doing just fine according to two very credible Chinese researchers, and then it just stopped spinning. We're going to be consumed by natural disasters.
The magnetic field collapses, the atmosphere collapses, all hell breaks loose, and now we have scientists at Beijing University saying it's happening. When an earthquake happens, shock waves go bouncing around the inside of the Earth through the core and creates echoes. A computer then analyzes the echoes and then pieces it together. That's how we know what the core of the Earth looks like. And we find out that yes, indeed, the core has come to a halt.
The Earth's rotation causes it to bulge slightly at the equator and flatten at the poles, a phenomenon known as oblateness. This oblateness is a result of centrifugal force, which pushes matter away from the rotation axis towards the equator. If the Earth stopped spinning, this force would cease to exist, and the planet's gravity would start to pull the excess equatorial mass towards the poles. Over millions of years, the Earth would likely become a perfect sphere. This reshaping would also affect Earth's gravitational field. Currently, the gravitational pull is slightly weaker at the equator due to the centrifugal force. But in a non-spinning Earth, the gravitational pull would be uniform across the planet's surface, meaning objects would weigh slightly more at the equator than they do today. The Earth's rotation plays a crucial role in distributing solar heat across its surface, leading to the formation of climate zones and driving weather patterns. On a stationary Earth, one side would perpetually face the sun, and the other would be in constant darkness. The side facing the sun would experience extreme heat, turning it into a barren desert, while the dark side would be trapped in perpetual freezing night. The stark temperature difference between the two hemispheres would create intense winds and storms as hot air from the day side rushes towards the cold side. Additionally, the lack of rotation would disrupt the Coriolis effect, a force that steers wind and ocean currents and significantly influences weather patterns. As a result, our familiar weather systems would be replaced by unfamiliar and potentially more extreme weather phenomena. The drastic climate change caused by Earth's cessation of rotation would have severe consequences for life as we know it. The extreme temperatures on the day and night side would make most of Earth uninhabitable for current life forms. Even in the relatively mild twilight zone between the day and the night sides, life would likely struggle to adapt to the new conditions. Photosynthetic organisms, such as plants and certain types of bacteria, would be especially affected. These organisms rely on a regular cycle of light and dark to function, and a constant day or night would disrupt this cycle. This could potentially cause a collapse of the food chain, with catastrophic effects for all life on Earth. From the above, it is clear that Earth's rotation is a fundamental factor that shapes our planet's physical features, climate, and ecosystems. Without it, the Earth would be radically different and much less hospitable place. This underlines the importance of seemingly simple physical principles in creating the conditions necessary for life as we know it. The thought experiment of a non-spinning Earth also serves as a reminder of the delicate balance that sustains life on our planet. It highlights the interconnectedness of physical processes and ecosystems, and the potential catastrophic effects of disrupting this balance. This understanding should guide us in our actions and decisions to ensure that we do not inadvertently disrupt the precious balance that sustains life on Earth.
And we know that the Earth is dynamic, like the North Pole, for example. The North Pole is moving. Believe it or not, every year you can actually calculate the rate at which the North Pole moves.
Yes.
And so, yes, the Earth is dynamic. We have to get rid of this idea that it's solid like the Earth.
Yes.
No, it's not so solid.
In contemplating this scenario, we come to appreciate the delicate balance that sustains life on our planet. It's a poignant reminder of our responsibility to understand and preserve this balance. This perspective is particularly relevant today as we grapple with environmental challenges like climate change and biodiversity loss. The consequences of disrupting the Earth's delicate balance may not be as immediate or drastic as the Earth stopping its rotation, but they could be just as profound in the long term. Let us know what you think about this scenario of Earth stopping its spinning. And don't forget to subscribe for more thought-provoking content from us. See you in the following video.